So right over here, we have the graph of the function f, and we're assuming that f is a function of t. Our horizontal axis here is the t-axis. So that is f of t, lowercase f of t. And now let's define another function. Let's call it capital F of, and it's not going to be a function of t, it's going to be a function of x. So capital F of x is equal to, we're going to define it as the definite integral between t is equal to -5 and t is equal to x. Actually, let me make those x's in the same color so they really stand out. So f of x is equal to the definite integral between t is equal to -5 and t is equal to x of f of t dt. And if I had my druthers, I probably wouldn't use capital F and lowercase f. I would use like a G or capital G just so that when I say f, you don't get confused. But I'm going to try my best to say lowercase f of t, capital F of x. So this is how we're going to define the function capital f of x. It's definite integral between t is equal to -5 and x of f of t dt. Now, given this definition, what I want to think about is at what x values does capital F of x, equal 0? So let me write that down. At what x values does this equation, at what x values is this equation true? And I encourage you to pause this video right now and try to think about it on your own, and then we can work through it together. So I'm assuming you've had a go at it. So let's just think about what this function capital F of x is really talking about. Well, it's the one way to think about it is it's the area below between between t equals -5 and t equals x, that is below the function f of t and above the t-axis. And if the area is the other way around, if it's below the t-axis and above the function, it's going to be negative area. So we're looking at t equals -5, which is this, you could say this boundary right over here. That is t is equal to -5. And if you pick an x value, let's just say x were -2. So if that is your x value right over here, capital F would describe this area. And this area, it would be a negative area because here the function is below the t-axis. So for example, capital F of -2 would be negative. Now, what x values makes this a 0? So one might jump out at you. Well, if we put x right at -5, then there's no width here. There's not going to be any area. So f of capital F of -5, I should be clear here, capital F of -5, which is equal to the definite integral between t is equal to -5 and t is equal to -5 of f of t dt, f of d dt. Well, you have the same boundaries here, so this is going to be 0. Once again, this area, you have no width to this area, so this is going to be equal to 0. So we can list x equals -5 as being one of the points, one of the x values that makes capital F of x equal 0. But let's see if we can find more of them. So let's see if we were to go, let me erase this right over here. We're starting at t equals -5. Now as x gets larger and larger and larger, when x is equal to -3, our area, so let's see, this area right over here, is going to be, so that is, let's see, we have, it's 2, going from -5 to -3 is 2, so this distance right over here is 2. This height right over here is 4. So this area right over here is 2 times 4 times 1/2, which is going to be 4. And since it's above the function and below the t-axis, we'll write this as a negative. We'll write that as a -4. And now, so let's see. So we're starting when x is equal to 5, capital F of x is equal to 0. Then as you get further and further out, you're getting more and more negative values, and it's more and more negative values. But I just picked out this point right over here because this seems like a point of transition of the function. And then we have this region, which is just going to add more negative area to capital F of x as x gets larger and larger and larger. And this looks like really a quarter circle. It has a quarter circle of radius 4. And now we have another quarter circle of radius 4 until we get to x equals 5. And this is actually going to be positive area because here our function is above the t-axis. So when we've gotten this far, so the way I'm thinking about it, when capital F of x equal negative 5 is 0, and now our area, as x becomes larger and larger and larger, our area becomes negative, 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 negative. Now it becomes less negative because we're starting to add. So for example, if x is equal to 2, we would be looking at this positive, but we still have all this huge negative area to overcome. So we're still in negative territory. But the more positive we add, we're going to become less negative. And you go all the way to x equals positive 5. And this positive area, this quarter circle right over here, positive area, is going to exactly offset this quarter circle of negative area. You don't even have to think about what that area is, although you can obviously figure it out with pi r squared and whatever else. And so now we just have to keep adding more positive area to offset this negative 4. So how do we do that? Well, the height right over here is 4. The height right over here is 4. So if we can add a rectangle that is 1 wide and 4 high, that's positive area of 4, which this has right over here. So this is plus 4, is going to offset this negative 4. And so we go all the way to x is equal to 6. When x is equal to 6, capital F of x is going to be equal to 0. Let's write that down. So capital F of positive 6, which is going to be equal to the definite integral between negative 5 and positive 6 of f of t dt. Well, we can break this up. We already went through it. I'm just going to make sure that we really understood what was going on. This is equal to, and I'll just do it all in one color now. This is equal to, actually I'll do it in these colors that I did here. This is equal to the integral between negative 5 and negative 3 of f of t dt plus the integral between negative 3 and 1 of f of t dt plus the integral between 1 and 5 of f of t dt. That describes this right over here. And then finally, plus the definite integral between 5 and 6 of f of t dt. And this describes this negative area. This describes this positive area. These two net out to be 0. And then this area we already figured out is, or this definite integral, I should say, is negative 4. This is negative 4. And this one right over here is positive 4. And so they net out. And this, of course, is equal to 0, which we wanted to figure out. Once again, how did I do that? Well, I said, okay, clearly when x is equal to negative 5, you have no area. And then I just kept increasing x's to larger and larger values. I could have gone actually the other way, and I would have had just more and more positive values, and there would have been nothing to offset it to get us back to 0. But as we increased x above negative 5, the capital F of x, the area, is more and more and more and more and more negative, but then we start adding positive value to it to offset the negative, and we fully offset the negative at x is equal to 6.